Welcome to CW 4.5. Today we're going to be talking about what happens when there is no horizontal asymptote. So recall case 3 from a couple of days ago. So write this function down. This is some generic rational function. Case 3 is a situation where there is no horizontal asymptote, and you might recall that happens if m, the top, is greater than n, the bottom. There is no HA. That's what we covered a few days ago. What you're going to learn today is that what happens is there's what's called a slant asymptote, or SA. And some books even call it oblique. So depending on your Algebra 2 teacher, this is an optional topic in Algebra 2B. So some teachers do cover it, others don't. Either way, we're going to cover it in pre-calc right now. So you're going to see this first example. You're going to notice that this is a situation where there is no horizontal asymptote, or in case 3, the top is greater than the bottom. So we know it's going to happen. Before we do anything, I'm going to draw a box just to contain all our information. So I recommend you do the same too. Get a little rectangle here. And to make it easier, let's factor this. That would be x minus 5 and x plus 1. That way I can see everything a little bit easier. So now I can see my x-intercept is going to be 5, negative 1. My y-intercept, that'll be 5 over 3. My VA is x equals 3. And now, remember, there is no horizontal. There's a slant asymptote. So we'll write slant. Now, the way you generate it is you just do long division. So you're going to grab your original problem right here, and you're going to just divide. Like this. So now let's actually do it. So x, let's multiply x squared minus 3x, subtract the quantity, and then do it again. That'd be negative x minus 5. We're going to put minus 1 here, then negative x plus 3, subtract, we get negative 8. So we have x minus 1 plus negative 8 over x minus 3. What's really cool is this thing right here, that is your slant asymptote. So we're going to write the slant asymptote is y is equal to x minus 1. Now, if you're wondering what happened, essentially what we just did is we took our original problem, we did long division, and we rewrote it in this form, meaning this problem is equivalent to this thing right here. Now imagine you were to plug in infinity here. So I just write that in. Imagine you plug in infinity here, infinity here. This thing will go to 0 because it's a constant over infinity. This thing doesn't matter. And we're left with this expression, x minus 1 or infinity minus 1, which means the graph will tend towards infinity, but to be more specific, it'll tend towards x minus 1. So it'll make more sense as we graph it. I'll do blue. Let's put our asymptotes down. So I have x equals 3, so I'll put that right here. And then x minus 1, so I'll just put a point here, negative 1, and go up 1 over 1. Okay, so there's our asymptotes. Let's put our points down. The x-intercept is 5 and negative 1. So I have this point right here, 5, 0, negative 1, 0, and intercept of 5 over 3. So that would be 1 2/3, about here. So I'll put 0, 5 over 3. Okay, so notice that's pretty good. Now, unfortunately, we can't actually just graph it quite yet because there's one thing we have to do. Remember that with horizontals, we have to check if it crossed. So for slant asymptotes, you have to check that as well. So we're going to check if there's a cross on the slant asymptote. So to do that, it's actually pretty similar to what you've already did in the past. You get your original function, your x squared minus 4x minus 5 over x minus 3, and you make it equal to your slant asymptote, which in our case is right here, x minus 1. We're going to solve it. I get x squared minus 4x minus 5 equals x squared minus 4x plus 3. Notice how the x's all cancel out, and we're left with negative 5 equals 3, which we know is crazy. Therefore, there is no cross. And remember, this is actually really important because that tells you when you graph, nothing can cross any asymptote. So now that we have that information, we put it together. I know that I can't cross my slant, so this thing will just approach it forever. And this is going to approach my vertical asymptote. And same thing here, approach my slant. And then I'm going to approach the vertical asymptote up here. Okay, and that would be the entire lesson. Now, I do want you to practice it just to make sure you have these mechanics down before you do the practice problems. So there's a checkpoint. It's very similar. So try this on your own. And I put the answers right here, so you can pause it and then check your answers once you're done with this example. But that's it for the lesson, and I'll see you next time.